Today we're going to be looking at solving an inequality with variables on both sides. And I'm going to make the numbers a little bit more difficult for this one. I'm going to throw in decimals and fractions. So the process would still be exactly the same as what we would do with integers. We just have harder numbers to work with. Okay. So with this one, I got 2.5 times 3x minus 1.2 in brackets. And that should be greater than 1.5x plus 5.4. So my first step is going to be distributive property to multiply that 2.5 into the brackets. So everything in the brackets gets multiplied by that 2.5. So I have 7.5x minus 3. Okay, should be greater than 1.5x plus 5.4. Okay, and so now I'm going to push all my variables onto one side. So I'm going to get rid of the 1.5x because it is smaller in value than 7.5x, or at least the coefficient is smaller. Okay, and that now leaves me with 6x minus 3 is greater than 5.4. And I'm going to get rid of the constant on both sides, so I'm going to add 3. And that now gives me 6x is greater than 8.4. And when we divide both sides by 6, we get that x must be greater than 1.4. Okay, so it's pretty much the same thing as what we would do with integers, but we just have harder values to work with. Okay, so I'm going to test that boundary point, so I'm going to go through and verify the solution. So we are testing the boundary point of 1.4. So every time there's an x now, I'm going to replace that x with a 1.4. Okay, so instead of x, we put in the 1.4. Okay, and I'll work through this side here. So 3 times 1.4 gives us 4.2, and 4.2 minus 1.2 gives us 3, and 2.5 times 3 is 7.5. On the right hand side, 1.5, instead of x, we're going to put in the 1.4, and then we are adding the 5.4 after. 1.5 times 2.4 is 2.1, and 2.1 plus 5.4 is 7.5. So we do have the same thing on both sides when we substitute the boundary point back in as if it was an equation. The second thing is to make sure that x actually should be bigger than 1.4. So I'm going to try, I'm going to pick 10 as a nice value because it's just easy to multiply by 10. So instead of x, I'm going to fill in my value of 10, putting it back into the original inequality. Okay, and on the right hand side the same thing. Instead of x, I'm going to fill in that value of 10, and I still have that plus 5.4. So I'll just work down the left hand side to start with, and then I'll move over to the right. So 3 times 10 is 30, and 30 minus 1.2 gives me 28.8, and 28.8 times 2.5 gives me a value of 72. Okay, now throughout that whole thing, the left hand side should be greater than the right hand side. So 1.5 times 10 is 15, plus 5.4 gives me 20.4, and it is very clear that 72 is greater than 20.4. So since this inequality here is true, that means that the numbers do need to be bigger than 1.4, and we know that 1.4 was our boundary point. So this solution of x is greater than 1.4 is the solution for this entire inequality. Okay, let's move on to one with fractions. So I've got this one here. We have 3x plus 6 is divided by 5 should be less than or equal to 4x minus 3 over top of 3. Okay, now I have two options for how to handle this one. The way I like to do it is I like to get rid of those numbers in the denominator. So the way I get rid of those numbers in the denominator is I would simply multiply both sides by the common denominator. So because these two, the 5 and the 3, they would have a common denominator of 15, that's what I'm going to multiply both sides by. Okay, so my first thing I'm going to do is multiply both sides by 15. And I'll just put it on the outside there so it's a little bit easier. Multiplying both sides by 15, what that allows me to do is it allows me to say, well, 15 divided by 5 would be 3. So instead of multiplying by 15 into the brackets and then dividing by 5 after, it's like just multiplying by 3 into the brackets. Same thing on the right hand side, 15 divided by 3, those guys reduce to 5 over 1. So now I've really simplified this. I still have to do distributive property, but as you look at it simplified, I've gotten rid of all of my fractions. And now I'm just working with integers. So this is much simpler. Okay, so I still have distributive property that I need to throw in here. So I'm going to multiply everything inside the brackets by what was sitting out front. Okay, and so now I have 9x plus 18 should be less than or equal to 20x minus 15. Okay, now I'm going to push all my variables this time onto the right hand side because 20x is larger than 9x. So I'm going to get rid of the 9x because that's going to leave me with a positive coefficient. And since I have a positive coefficient for x, when I divide both sides by that 11, I'm not going to need to flip my inequality symbol. And that is a step that when we're so busy with other things we often forget. So if I just remove that obstacle early on, I generally get it right. Okay, so now I'm going to divide both sides by the 11, and we get 3 is less than or equal to x. Okay, alright, so got rid of the fractions by using that common denominator, and then all we had was integers. Used distributive property, pushed all the variables onto one side, removed the constant, divided by the coefficient. Okay, now the other way I could have done that, and you don't need to do it this way, I think it's a little bit harder. I could divide everything in the numerator by what's in the denominator. Okay, so I could have 3x over 5 plus 6 over 5 is less than or equal to, and on the other side it would be 4x over 3, right? I divide that first term by the 3. And then the second one is negative 3 divided by 3, so that's a minus 1. But now I'm working through everything with fractions. I think it's a little bit more difficult. Certainly not, it's certainly manageable, but when we have a way of dealing with it where we can work with integers, it seems much simpler. Okay, regardless of the way you solve it, okay, we said that 3 was our boundary point, so I've got to go back in, and I've got to solve to make sure that if I put that boundary point back in, that we do in fact have a left side equal to the right side. So I'm going to put that boundary point of 3 back into my fractions. So 3 times 3 is 9, 9 plus 6 is 15, and 15 over 5 is simply 3. We'll do the same thing on the right hand side. Instead of putting in x, we'll put in 3. And so we have 4 times 3, which is 12. 12 minus 3, which is 9, and 9 over 3, which is just 3. So we have that same value of 3 on both sides. Interesting that it also ended up equaling the boundary point, but certainly not necessary. Okay. The last thing we need to check is we made a statement that said that 3 should be less than or equal to x, okay, which means x has to be bigger than 3. I don't know, I'm just going to try, doesn't really matter, I'm just going to try something random. Let's say x is 18. Okay, so I'm going to fill in, instead of x, every time there's an x, I'm going to fill in 18. And we'll see if this inequality is still true. Okay, and on the other side 4 times, put in that 18. And we'll see how I did. Maybe my numbers were no good, I don't know. Alright, so 3 times 18 gives us 54. And then we have 54 plus 6, and that's all over 5. 54 plus 6 is 60 over 5, and 60 over 5 is the same thing as 12. Okay, that side worked out nice. It's kind of convenient. Let's see the other side. So we've got 4 times 18, so that would be 72. 72 minus 3 is 69. 69 over 3 is 23. And so we have a true statement. 12 is smaller than or equal to 23. So we did a good job. That's true. So that means if we were to go back, our solution, we verified the boundary point, so 3 is the boundary point. We said x does need to be bigger, so this down here is the solution. It covers all the possible answers that would make our original inequality true. Okay. One last example. What if I don't have a nice common denominator I can use to get rid of everything? Can I go through it with the fractions? Okay, so let's just try here. This one I'm going to use distributive property. I'm going to bring in that 1/2. So this is going to give me 3 over 4. Sorry, did the wrong color. So I get 3 over 4 x plus 1 over 8. And on the other side we just have 3 over 5 x plus 1.2. Okay, 3 over 4, that's like 75%. 3 over 5 is 60%, so 75% is bigger. So I'm going to subtract the 3 over 5x from both sides. Now I don't really know what this is off the top of my head, 3 over 4x minus 3 over 5x. I need to have a common denominator, so I'm going to look at their coefficients. Let's say I had 3 over 4 minus 3 over 5. That's the same thing as having a common denominator of 20 and saying 15 over 20 minus 12 over 20, and that equals 3 over 20. Okay, so this here, I'm going to rewrite it now as 3 over 20. So I have 3 over 20 x, don't forget to bring the x back, plus 1/8. It should be larger than 1/2. Okay, well now I got to get rid of my constant on both sides, so I need to subtract 1/8 from both sides. Now this one should be a little bit easier to do in your head. 1/8, I need to have a common denominator of 8. So 1/2 is the same thing as 4/8. 4/8 minus 1/8 would leave me with 3/8. Okay, and to get rid of my coefficient, I need to multiply both sides by the reciprocal. So my coefficient is 3 over 20. The reciprocal is 20 over 3. I have to do the same thing on the left and right. On the right hand side, my 3's cross-reduce, turn into 1's. And I also have the 8 and the 20 have a common factor of 4, so that leaves me with 2 and 5. On the left hand side, the 20 and 20 and 3 and the 3, everything cancels out nicely there. So now we are left with x is greater than 5 over 2. Okay, so still not that bad to work through the whole thing with fractions. Definitely manageable. I won't give you anything that's that crazy. Okay, now check the boundary point. This is where it's tough if your answer is a fraction. So I'm going to put it back in. So we had that boundary point of 5 over 2. So I'll work with the left side first. Okay, so instead of x, I fill in 5 over 2. Alright, so now 3 over 2 times 5 over 2. No cross-reducing, so that's 15 over 4. And 15 over 4 plus 1 over 4 is 16 over 4. And 16 over 4 is just 4. And then 1/2 times 4 ends up being 2. That's simplified actually quite nicely. Alright, on the other side here we got 3 over 5. Instead of x, we're going to put in that value of 5 over 2. And then we still have to add the 1/2. Okay. This one's nice. The 5's cross-reduce, and we get 3 over 2 plus 1 over 2. So 3/2 plus 1/2, and that's 4/2, and that's 2. So there we go. We've got the left side and the right side are equal when we substitute that boundary point back in. Okay. The second part, we said that x was greater than 5 over 2. So I have to try something that's bigger than 5 over 2. Again, I don't know. I'm just going to try something nice like x is 10. Okay, easy to multiply by 10. And when I look at my fractions, I think it's going to get rid of my denominators because 10 is a multiple of those denominators. So let's look. I got 1/2 times 3 over 2, and instead of writing x, I'm going to fill in 10. And then we've got plus 1/4. Should be greater than 3 over 5, and again, instead of x, I'm going to fill in that value of 10, and we're going to still add that 1/2. Okay. Alright, let's look on the left side. I'll probably just do the left side and we'll come back to the right. Okay, so this is 1 over 2 times, so 3 over 2 times, we'll say 10 over 1. times, that's a terrible x, I apologize. Okay, the 10 and the 2 can cross reduce, so that becomes a 1 and that becomes a 5. Okay, and then I just have 1s in the denominator, so I really just have 15. Okay, and I've got 15 plus 1/4. Okay, and then on the with this one here, that's 15 and 1/4. And since I'm going to multiply by half, this doesn't really work for me to have it as a mixed number, so I'm going to change it to improper. 15 times 4 would give me 60, so I really have 61/4. If I have 15 and 1/4, it's the same as 61/4. And that then becomes 61/8. That's not a great value. I'll think of that one as a mixed value. Instead, 8 can go into 61. It goes in 7 full times. 7 times 8 is 56. And we got 5 pieces left over. Probably easier to compare with the other thing once we've got it as a mixed number. Okay, let's look back at the right-hand side. So we had 3/5 times 10. So that really, those guys cross-reduce. And that becomes 6 plus 1/2. 6 plus 1/2, that's just 6 1/2. It's really easy. So I just need to write that a few times here, keep that going down the right side. And it is true that 7 5/8 is bigger than 6 1/2. So that's true. So we verified that the inequality symbol was facing the right way. We verified that 5/2 was the boundary point. So this that we have down here, we've got our x is greater than 5/2 is all of the possible solutions that make this original inequality all the way up here true. Okay. All right, that's solving inequalities when you got variables on both sides, dealing with decimals and fractions. All right, guys, have a good week.